Hello everyone and welcome to the STM32 Microcontroller tutorials. In this tutorial, we explain how to properly configure and use interrupts in STM32 microcontrollers. Interrupts are very important components of microcontrollers which enable us to temporarily interrupt the code that is currently running and to run another function or a piece of code that can handle an external event. For example, in mechatronics and control systems, interrupts can be used to read and process encoder pulse readings. To demonstrate how to use interrupts, we created a simple circuit shown over here. This circuit will turn on or off this LED by pressing this button. For example, if I press this button, the LED will be turned on. Then again, if I press the button again, the LED will turn off. This switching is achieved by assigning the interrupt to the pin attached to the button. We actually attached the interrupt to this pin over here. If the interrupt pin detects a rising edge that is created by pressing the button, then the current execution of the code will stop and another function will be called. This function is called the interrupt handler or interrupt service routine. The interrupt service routine is also abbreviated as ISR. The interrupt handler function sends high or low voltage to the pin that is attached to the LED diode and the resistor that limits the current that flows through the LED diode. We use this pin D4 as an output pin, and the function will send high or low voltage to this pin that will turn on or off this diode. I will explain this circuit later on in this video tutorial. But before I start with explanations, I need to mention the following. It took me a significant amount of time, energy, and planning to create this completely free video tutorial, as well as almost 500 free video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start with explanations. First, we will explain this wiring diagram. We are using a Nucleo 64 board with the product number F446RE. However, everything explained in this video tutorial can be used in the case of any other STM32 board or STM32 microcontroller. This circuit over here will turn on or off this LED. LED is an abbreviation for light emitting diode. We will change the state or turn on or turn off this diode by pressing this button or by pressing this switch. If we press the button, the LED will turn on. Then, if we press the button again, the LED will turn off. This is achieved by assigning the interrupt to the pin attached to the button. That is, we will assign an interrupt to this pin D7 or PA8 of STM32 microcontroller. Let us first explain the button circuit. Here it is. Our button has two ports. This port over here, represented by the red circle, is actually attached to the 3.3 volt pin of STM32 microcontroller. This pin provides a constant 3.3 volt, and by using this button, we will either open or close this circuit. The second port of this button, represented by this blue circle, is attached to the pin D7 of STM32. The internal notation for pin D7 is actually PA8, and this is very important to keep in mind. Over here we have a 1000 ohm pull-down resistor that's attached to the ground of our STM32 microcontroller. Let's explain this circuit. When the button is not pressed, on this pin over here, STM32 microcontroller will detect zero voltage. That is, it will detect the ground voltage. On the other hand, when we press this button or when we press this switch, this circuit will be closed, and on this pin we will detect the rising edge. That is, the voltage will go from 0 to 3.3 volts. Since by pressing this button the voltage will rise from 0 to 3.3 volts, we will configure the interrupt attached to this pin to be a rising edge interrupt. If the interrupt pin, that is, if this pin D7 detects a rising edge, then the current execution of the code will stop, and an interrupt function is called. This interrupt function is also called the interrupt handler or the interrupt service routine, which is also abbreviated as ISR. This interrupt handler function will send high or low voltage to the pin that's attached to our LED. Next, let's explain this LED circuit. Here it is. This white wire is coming out of the pin D4 of our STM32 microcontroller. The internal name or the internal notation for this pin D4 is actually PB5. Then we have a 220 ohm resistor that's used to limit the current through our LED, and the end of LED is attached to the ground of STM32 microcontroller. Here's the summary of the working principle of this circuit and the interrupt function. If we press this button over here, the interrupt attached to the pin D7 will detect a rising edge. That is, it will detect that the voltage increased from 0 to 3.3 volt. Then the interrupt function will be called, and this interrupt function will send either high or low voltage to the pin D4. If the high voltage is sent, that is if 3.3 volt is sent, then the LED will actually emit light, and that's it. Here you should keep in mind that due to the simplicity and brevity of this video tutorial, we didn't implement a button debouncing mechanism. This mechanism can be implemented in software or designing a simple capacitor resistor circuit and adding it after this end port of our button. Next, we explain how to write a C code that will achieve this functionality. However, before you even start thinking of writing the code, you first need to download your board schematics. So open Google and search your board number. In my case, it's F446RE. Then let's click on this link, and over here click on documentation. You need to find the proper file. That is, you need to find the proper user manual. Here's my user manual. Then download the user manual and open the user manual. Then search for your board number. Here it is. This is the schematic that you need to find. The next question is, why is this schematic so important? Well, it's important mainly because on your board you will see that pins are denoted by D0, D1, D2, D3, or A5, A4, A3, etc. However, this notation is not the internal notation used when coding your STM32 microcontroller. In fact, you need to use these pin names. We need two names. Our output pin that will light or turn on, better to say, or turn off the LED diode is D4. The internal notation for this pin or the internal name is PB5. This is very important to remember. Then we will use this D7 pin to attach the interrupt to that pin. However, the internal name of this pin is PA8. So we need to remember two names, PA8 for the interrupt pin and PB5 for the output pin. The next step is to open the STM32 microcontroller development environment. So click on Start and search for STM32. In my case, I'm using the STM32 Cube IDE. And here it is. To start a new project, click on File, click on New, and click on STM32 Project. Over here, you need to select your board. So click on Board Selector, and over here you need to search for the part number. Type Nucleo 64, and you will see it over here. Let me just do it once more. For some reason it's not doing it right now. Okay, here it is. Then click over here, and over here you need to find your board number. So scroll down until you find your board number. Here it is. Here's my board. Okay, click on Next. Give the name to your project. Let's call the project Interrupt 1. And click on Finish. And click on Yes. Be patient here. And after some time, you will see this nice graph over here. That is, you will see your chip with all the pins. Okay, let's first do the easy part. Go back to the board schematics. We will use this pin PB5 to be the output pin that will turn on or off our LED. Go back to the cube development environment and find PB5. So where is PB5? Let's search for it. Let's see, it's not here. Let's see over here, it's not here. And here it is, here's PB5. Then click on PB5, and over here you need to find this option, GPIO output. Click on that option. Perfect. Next, let us go back to our schematics, and over here we can see that the interrupt pin is D7 and the internal name is PA8. Let's go back to our cube development environment and let's search for PA8. Here is PA8. Click on PA8. The PA8 should be actually the interrupt pin. And over here we are using the external interrupt pin. Consequently, we need to select this option. External interrupt 8. Click on this option. Good. Next, let's configure these pins. First of all, click on System Core and click on GPIO. Expand this screen. Okay, so let's analyze what's written over here. Here is PA5. We are not using this one. PA8, here it is. Let's see what's written over here. External interrupt, perfect. So we'll be using this one. And let's click on this thing. Now, over here, we need to select the correct option. Let's see what's written over here. GPIO mode, external interrupt mode with rising edge trigger detection. Perfect. We need the rising edge. Then, over here, you have the option to select a pull up or pull down resistor. Since we are using the external hardware resistor, we will not play with this option and we will use the default option. No pull up and no pull down. However, you don't need to have a hardware resistor to have a pull up or pull down. You can simply configure this interrupt pin to add a pull up or pull down resistor functionality. Next, you need to click on NVIC menu, and over here you need to enable this interrupt. You will enable the interrupt by actually enabling this line from 5 to 9. Since our interrupt is number 8, this is actually in this range, so you need to enable this. This is very important. Next, click over here on GPIO and click on PB5. The PB5 is actually the output. Here we will use the default option, we will use the output push-pull, and we will not change anything about this pin. However, you can also just confirm this option to make this menu to be modified. And that's it. Next, click on NVIC. over here you can change the priority of your interrupt pin. Here's our interrupt. It's actually on the line from 5 to 9, and over here you can change the priority. I'm not going to play with this option, however, by changing this number over here you can set the priority. After this, we need to automatically generate the code. To do that, click on Project and click on Generate Code and click on Yes. And over here you need to be patient. You can also automatically generate the code by clicking over here. This development environment is smart enough to automatically open the main.c file. However, if for some reason this development environment doesn't open this file, you can find this file by expanding the core, clicking on the source and double-clicking on the main file. Over here we will modify the main file in order to write our own interrupt function. This code is automatically generated by our development environment. However, it's still a good idea to read this file and to analyze the code. Let's scroll down. Here is our main function. We will actually not modify this main function. This is mainly because we will write a separate function outside of the main function that will handle the interrupt events. Scroll down. You see this function. This function will initialize all the pins and will actually implement everything that we graphically configured. So let's search for declaration of this function. You can find the declaration by do the right click and click on Open Declaration. And here it is. The declaration is actually in the main.c file. Let's scroll down. We can see a few things over here. Where are the R pins? Here's the pin 8. This is PA8. Very interesting. This pin will actually be the interrupt pin. And here's the PB5. This is our output pin. So we have 8 and we have 5. And then we can see these functions. Obviously, these functions are related to our interrupt. And they simply properly set up our interrupt. They set the priority and they enable the interrupt. The development environment has actually generated a function that's used to handle the interrupt events. However, we are not going to use directly that function. Instead, we will write the function inside of our main file. However, it's still a good idea to look into the proper prototype and the form of the function for handling the interrupts. To do that, notice this function HAL GPIO initialize. We need to open the file that contains the declaration of this function. Okay, so here it is, HAL GPIO.c. Now, if you scroll down, if you go all the way down, and if you keep on going down, you should see a function that looks very similar to the function that we will actually write for handling the interrupt events. And here it is. It's called HAL GPIO XT callback. This is a callback function. And note what's written over here. This function should not be modified. When the callback is needed, the HAL GPIO XT callback could be implemented in the user file. And that's what we will do. However, here it's very important to see this declaration. We need to exactly write this. Void HAL GPIO XT callback, and we need to specify this input argument. And inside of this function, in the main file, we will actually rewrite this function. Next, let's go back to the main file. Scroll to the top of the main file. Over here, somewhere, we need to add our code. I will add the code between these comments. And here, keep in mind that it's always a good idea to add your code between these comments. If you don't do that, you might have a problem if you try to change something in this graphics user configuration menu. For example, if I change something over here and if I regenerate my code, that is, if I click on project and generate code, everything written outside of these comments will be erased. For example, if you declared your function over here, and if you regenerate the code, this part will be erased. However, the part that's in between these comments will not be erased. And here's my function. Let me explain what's happening over here. First of all, keep in mind that over here I define this variable pin state that's equal to 1. The type is GPIO pin state. This variable type is actually defined by the HAL library. Don't worry about it. This is just an integer value. It can be 0 or 1, or better to say Boolean variable. Okay, next, here's our interrupt callback function. Now, you can see that it's void. You can observe this name, and you can observe this input argument. This is precisely the definition given over here. And don't worry about it. You have here weak. This weak actually means that you can override this function declaration in your main.c file. So don't worry about it. Okay. But what is very important is to have the same name. Now, what's happening inside of this function? If actually this function is called, that is, if the event is detected and the event is actually the rising edge on our pin, and if the detected pin is GPIO pin 8, then over here, what do? We use this function to write to the PB5 pin state. Initially, the pin state is 1. 1 means that we are writing the high voltage. Let me explain this function. This is the standard HAL function for sending high or low voltage to the certain pin. Since the pin is PB5, the port is B, and over here you need to use GPIO-B. If, for example, you had PA5, then here you will have GPIO-A. Then, since we are sending the voltage to the pin PB5, here you need to specify the name of the pin. The pin is pin 5, GPIO pin 5, and over here is the state. And that's it. And over here, what do? We simply change the value of pin state. After we send the voltage, if the value is 0, currently in the next call of our callback function, it will be 1. Else, if the pin state is actually 1, we set it to 0. And in that way, we achieve the following. If you press the button and LED was off before pressing the button, the LED will be on. Similarly, if the LED was on before pressing the button, after you press the button, the LED will be off. And that's it. Simple as that. Now, keep in mind over here that we didn't modify our main function. This is mainly because we are not playing with sequential execution of the code. Over here, what's happening behind the scene, whatever is written in the main function will run. However, if an event happened, there will be a rising edge, and then the execution of the code will stop here, and this function will be called, and this code will be executed. Simple as that. The next step is to build the project. So click on Project and click on Build Project. And over here, expand this menu, and there are no errors. Let me repeat this. Project, Build, Project. Okay, no errors. The next step is to upload the code to your board. The upload process to the board is actually called the download process, so don't be confused by that. To download the code to our board, you can simply click on this button. So click over here and click on OK. And then wait for a while, monitor this section for errors. Let's see what will happen over here. And download verified successfully. That's it. Now, if I press my button, the LED will turn on, and then again, if I press the button, the LED will be off, and that's it. Okay, that will be all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.